Good morning, everyone. I'm your host, Sachi, and welcome to AI Minute Mondays. Today, we are diving into a topic that's part of the AI system, but it doesn't always get the spotlight. It's the infrastructure that makes modern apps reliable and ready for real users. And joining me today on AI Minute Mondays is Ravi Krishna, who's the CEO of FlintLab, a platform that unifies real devices, emulators, as well as cloud native execution to help teams ship mobile and web apps with confidence. Krishna, so happy to have you here on the show. And for the sake of our viewers, if you can share a little bit about your background, that would be great.
Thank you, Sachi. It's great to be here. I'm Krishna Seerapu, founder and the CEO of FlintLab. I've spent close to 25 years in software testing, automation, and device infrastructure, working across companies including Motorola, Microsoft, Amazon, and Google. One thing I learned throughout the journey is that software has evolved dramatically, right? But the infrastructure we use to test, it has not evolved at the same pace. Like if you see today, we have GCP, Azure, and AWS and all, where a lot of infrastructure is built around building applications, SaaS applications, or on-device applications, but it's not the same case with infrastructure. And at the same time, during my tenure in Amazon and Google and Microsoft, I had an opportunity to work on and build large scale test infrastructure and also the device test infrastructure like Kindle and Pixel phones and stuff. So I saw firsthand how difficult it is to manage this test infrastructure because most of the focus is on developer infrastructure
Yeah.
and managing these real devices and automating these complex scenarios. Let's say if you want to test like a last mile delivery, like an Uber or a DoorDash, you need multiple devices. Like, hey, you need to simulate like hundreds of drivers with customers requesting, or similarly for DoorDash, like there are hundreds of restaurants. So these simulations with a lot of conditions introduce a lot of failures. And to understand what went really well and what did not is always a pain, right? So that is where we started Flint Lab with all these learnings and want to build an AI native test and device infrastructure platform that brings together what you pretty much mentioned: real devices, virtual devices, simulation, observability, and AI powered analysis. So that's what, like when I left Google and started, our vision is not to simply to run more tests, it is to
Mhm.
help engineering teams to enhance their engineering productivity by understanding the failures faster, ship reliable with much greater confidence. That's how I put it. So.
Thank you, Krishna, for sharing that. Like you mentioned, Flint Lab is basically sitting at the intersection of automation, real device testing, and your developer workflows. But with AI now embedded in almost every app and every experience that we are seeing, what are the biggest shifts that you are seeing in how teams are building and validating AI powered applications? And how do traditional testing approaches do they work? Or do they break down, or it causes a completely new paradigm shift?
Yeah, that's a very great question. So I will try to answer this in threefold approach, right? So first, let me give a context. Like previously, the behavior of testing, right? Like, hey, they're more deterministic. Traditional testing was like, I'll not say straightforward, but it is more predictable. Like you perform an action, you know what is expected.
Mm.
But with AI-powered applications, right now, there is an agents running on device. There are agents running on cloud. Everywhere there's a lot of intelligence built on chip. Right? Like previously we have a system on chip concept, but that's more predictable now with AI and ML going into this chipset, silicon, everything. So it's very different outputs coming based on the context, model, data, network conditions, and also it's learning from the previous interactions. It's like self-healing things. So this is making things like, hey, if I run a test, so it's not like did the test pass because the behavior is changing. So it's about, is the behavior correct? Is it reliable? It is within the expected boundaries with a degree of freedom with what we call it as AI. So that's where the real challenges are going to be. And it's a continuous learning process. So the testing is becoming more difficult. On the second aspect, as I said, with all this non-deterministic results, how your environment itself is becoming much more complex. So what kind of environment you want to create to help people simulate these kind of scenarios and test it, that is getting more complex. An application may behave perfectly in one condition, but a mobile phone or a device which is running a chipset in Europe is different from US chipset. So the same test cannot run on emulator and the network conditions are different. Like if you go much more into the national parks, the connectivity is completely different. So this also brings a lot of challenges on how your infrastructure can simulate the real world environments along with the AI unpredictability to give a more defined results is what one of the biggest challenge. And now the number of devices are getting increased. If you see when I say device, it's not just mobile. An IoT is a device. Your camera is everything is a device
Yeah.
now. So it's with the cyber physical things are getting more complex. So the experience depends on how do you want to test it. So how do you want to test it is again where the real impact is what you're going to make. That's my third concept is where I think I can make a huge impact if we understand the failures right. And if we can understand the failures ahead of the time, right? That is something today engineers can spend no need to spend hours of time in analyzing the logs and all because now with a lot of AI tools, you can generate the code very faster. But to write an agent is easier. But if you want to test the evals, how is that agent supposed to perform? So it's really a complex testing. So where we need to analyze all the data like logs, screenshot, videos, device telemetry, abnormality, anomaly, and all those things, and give them instead saying, hey, the tests are failing is very simple answer, but the tests are not failing. The tests are failing because let's say you're doing an Uber delivery, the network changed, this is where the app crashed. So give more a defined results so that they can spend time in building features, not really analyzing the logs and stuff. So it's more like evidence-based
Mhm.
test and likely give the root cause. That is the direction we're also taking with FlintLab, moving from test execution to test intelligence platform. That's what we're working on. So,
Thank you. I like that. The test intelligence platform, primarily because if you look at it, like you mentioned, with AI, we are bringing in non determinism. It becomes far more complex for them to predict the outputs, to figure out what's going to work and what's not going to work.
mhm,
And like you mentioned, the performance and the scale of things is like increased so dramatically.
mhm,
Moving on to my next question. So, with these evolving platforms, compliance requirements, and growing device fragmentation, right? Like you mentioned, devices across different
mhm.
regions, and with the rise of AI generated applications, right? Pre release testing is now becoming increasingly complex. So,
Good.
how do you see AI influencing compliance, reliability, and even the release readiness over the next few years, right? And what role do platforms like FlintLab play in helping developers navigate this entire new landscape?
No, that's a very interesting question. So this is something what we've been also working, but I will first give an over a context on this. So the release readiness is going to become increasingly continuous learning process. That's where you're like there's no limit for an intelligence, right? So it's keep getting upgraded. So we already have, as you mentioned, enormous fragmentations across devices, geographic locations, the compliance rules, the data specific rules. And also there are a lot of networks and other platform requirements for simulations, as I said. So now we are adding AI generated and increasingly autonomous application behavior on top of that. So this makes more complex. So we can definitely do some manual testing, but nowadays, let's say even AI is generating like 10,000
Yeah.
tests. So if you want to really cater the tests and see, I don't want to run all my 10,000 tests, let's say simple right thing like if I'm testing an alcohol delivery scenario for a DoorDash or an Uber Eats in Europe, the alcohol consumption age limit changes from country to country.
Oh.
And the devices they use in each country in their geographical locations are different. Like maybe
Mm,
Europe is more Android and
mhm, mm,
this is for iOS. And
mm,
India, there is more low-end devices like Redmi, Xiaomi, Vivo. So this is where these combinations are also making a lot of complex. Like so, we have a full 5G, but not 5G in all Indian locations. So there are a lot of these combination things. So with that unpredictable results, right? AI will increasingly becoming part of the validation layer itself. So this is where we were talking about if you just say a bill and I want to say, hey, I want to do an alcohol delivery testing on the most frequently used devices.
mhm, mm,
So this is where FlintLab is building the intelligence platform, saying we automatically analyze on what are the most frequently used devices and what are the chipsets that are mostly used by the drivers in that locations, and we automatically brings up the devices for testing and orchestrate the entire test agents and then trigger the high risk scenarios or identify the high risk scenarios and configure the entire environment and execute those tests, analyze the results and highlights the potential reliability or compliance risks. So this is where helping us to say, hey, we were not just giving a platform,
mhm,
making your testing easier. So that is where I see platforms like FlintLab playing an important role. So want to provide an infrastructure underneath that intelligence. So
mm,
where it correlates everything, orchestrates what is really required, and then run the automation agents. And we built an inbuilt observability and AI-powered root cause analysis, which is we call RCA and stuff. So developers don't have to assemble all of this. So they can say, hey, now I want to test. Just I said alcohol delivery is a one simple. Like I'll say I want to release tomorrow YouTube Kids in China or YouTube Kids in Vietnam. So we take the conditions and we apply those intelligence and say, this is the tests that you have to work. So ultimately, I believe we are moving toward a world where testing infrastructure becomes increasingly autonomous now.
uh-huh,
So the developer should be able to ask, hey, as I simply said, I want to test the delivery scenario in South Africa tomorrow for Amazon.
mhm, mm,
That's where we actually do the demographics and everything, and we say what are the right set of environment and infrastructure is required. Then we will go with the agents and bots to uh, apply there to run the automation and then do the RCA. This is what we are currently focusing on, and the infrastructure should be able to answer now saying instead of hey this yes or no, we will give the clearly evidence and hey this is where this particular network conditions your app is breaking while doing the deliveries of alcohol, or there is a risk of people, younger age people delivering in US. So we need to be more compliance specific. So give that exact data so that the companies or organizations can act upon it rather than like
mm.
going through a lot of logs and doing a lot of data analysis is really getting simpler here. So that's the future we are building at FlintLab as well. So in pretty short, that's what when we say AI-powered infrastructure. So
Thank you, Krishna, for sharing that information. So, like you said, you're not just providing a testing platform, but you're also providing the test intelligence layer, which is
mhm,
helping take the load off developers. So,
mhm,
developers can give you a scenario and then you handle all of the aspects of figuring out what are the optimal test cases, not running, 100,000 tests, but running the high risk scenarios, running the right kind of test environments for their specific environment and for their specific use case.
yes.
So yeah, so that I think is a kind of it's simplifying the job that the developer does, so that the developer can focus more on
Mhm,
building the software and building the technologies, while you focus on helping them ease the complete testing burden and making the applications user ready, right,
yep.
and compliant. So yeah, so thank you for sharing that. That's super helpful and insightful for our viewers as well. And I hope many of them can take benefit of platforms like
Thank
FlintLab
you.
to basically, to ease all of their testing burden. And thank you for joining in for AI Minute Mondays. So happy to have you here. And that's all that we have in this episode.
Thank you so much, Sujit. Thanks for giving this opportunity. Thank you, everyone.